Okay, now I've got to go to LinkedIn.
And I'm going Facebook, and then I have to jump over there and manually turn it to public, which just blows my mind that... Oh, I might as well turn off MST3K. I have blathering in the background here. That's my go-to filler. Mystery Science Theater 3000.
Okay.
And now, here we go. So I have an iPad dedicated just to making... So I have a screen that I can make this public without getting echo. All right, Facebook, how you doing? I just posted a link. If you want to see this in its native environment, it's over at Altium Academy, where you guys try and teach people like me how to use the software, right?
Yeah, and there's more exciting things to come, hopefully.
Cool.
So I know
well,
I'm still distracted
we'll use
trying
the
to type on my LinkedIn thread.
Yeah. Oh, it's hard to talk and type at the same time when you're in entertainer mode. I usually, well, that's what producers do, right? They let the people talk and they worry about titles and stuff. Finishing sentences, things like that.
Yeah, that's why we need someone from the media team here to help us out so they can do all this stuff. And
I swear I'll get my son to help if I have to. He won't like that. He might like that. So, yeah, the biconical antenna, we can use the fact it's sitting right behind me as a lead for, as a teaser for future shows where we actually show you the effects of good layout, bad layout, random layout on your emissions. FCC, CE, VDE. Oh, I forget the Australian one. The old Australian one.
It used to be CTIC, and now it's just ATIC, which covers both electromagnetic compatibility and
safety.
Safety, yeah. So it applies to power supplies as well as,
it's the
unintentional
UL of yeah.
Yeah.
When
it's like UL and FCC combined.
I took my TV repair test at the age of 17 in Indiana and got it. I missed only one question on the test, and it was, there's a sticker on the power cord of a TV that says UL, what's it mean? And I put that the TV is UL listed. And of course the answer was the power cord was UL listed. And I knew it, but I'm like, are they doing double trick or are they being real about this question? And they were being a trick.
And that's why, you can get equipment from any part of the world and it'll have the CE on it.
Yeah. It's probably built right into the mold, whether you have CE or not. They just stamp it on there.
It doesn't really mean that much. What you need to do is ask for the certificate of compliance and see what's listed in that, because it could be safety, but it could be safety from chemicals, or it could be safety. Right. It may not be electric shock. It may be something else.
A finger test or something like that. Yeah.
Yeah. Plastic children's toys have CE certification.
Oh, okay.
As well, you'll see it's in the mold, in the injection mold.
Right, and so, in Underwriters Laboratories, you didn't actually need, unless you were in the old days, but Chicago and Los Angeles required it. So since the big cities required it, we always went for UL. But you didn't need UL to sell it legally. Just it depended where it was going. But so we always got UL. All right. What do you want to talk about? I got stuff.
Well, I did promise Cam and Marsha that we'd mention the competition.
Yes.
Because that is actually a pretty cool opportunity, and I know this is marketing, so sorry everyone.
No. Pays the bills, man. So
anyway, we've still got a couple of minutes before we start, so I'll save it. But I have some other really cool things. I went into my my workshop / shed. So I have a tough shed in my yard, and it's meant to be full of garden tools, but I found a way to really compact all the garden tools into one tiny corner so that the rest of the shed is room for electronic components, a workbench.
FCC testing. It's an outdoor oat site, right?
And on the opposite side, I set up a shelf to put the K40 laser cutters on there.
Oh,
the only problem is I'm in Escondido, California, and in summer it gets to 110 degrees here, and the shed is not air conditioned. I did run power into it, which is probably not to code, but don't tell anyone.
You just did.
I know it's safe.
It's safe. It's to code. I had a... Well, you're allowed to do your own wiring on your own house, but you should do it to code. But you're allowed.
I got a book. So I'm an electrical engineer, so I don't need a book to know how to run cables safely, right?
It's all about heat.
But I did get a book because I wanted to make sure I was doing it to code.
Right.
And oddly enough, this book that's really thick, it's just a general how electricity works and how to do wiring, published by Home Depot, and it's a fantastic book if you know nothing about electricity. And it shows you how to install things, but every example's done from the point of view of of a new dwelling, a new building structure, and so it shows how you run cables through walls and what height they need to be and normal heights for outlets and things like that. It does not.
But it also tells you the gauge of the wire based on the distance and whether it's in a conduit, and that's a heat equation at the end. It's fuses, big long fuses.
Yes, right? But it gives you no information about codes. And I discovered when I started inquiring about this with friends who are licensed electricians, they said, well, that's because the codes are different depending on what county you're in.
That's right.
Or what city you're in.
But there's National Electrical
changes.
Code. NEC is the one if you know NEC, then you're going to do good practice.
So the book was built on NEC, and so
very good.
And I know some of the things I did weren't exactly.
We'll talk offline about that. Hey, so I got two questions here. First off, I got a lot of people on Facebook today, guys. If I try and chat response in Facebook, it auto plays the video and I get echo and stuff. So I'll do the chat responses afterwards, but keep them coming. Somebody's asked, Evan, who used to run the VCFs, wants to know who you are. So you are from Altium.
Me?
That's, yeah.
Oh, okay. So yeah, I'm Ben Jordon. I'm an engineer. I've been at Altium for 15 and a half years. And so I have done everything from tech support to product management, which Bill and I were talking about before we went live, to marketing and.
Well, you found me, right, for Altium. You and me talking.
Yeah.
From a Hackaday thing that I actually missed, but you and I started talking about routers, and that led to me being a keynote for you guys.
It did. That was really cool. So actually, how that worked. This is a bit of interesting thing. How I met Bill. So Bill is a legend, and I feel deeply honored and privileged to meet someone like that who was a lead hardware designer for the Commodore 128, for example. Like, to me, that's awesome, because the first computer I actually used was a C64.
Right. Wonderful computer.
I borrowed a Commodore Amiga 500 off a friend many years later to do music on, which was fantastic.
Great computer.
But in my home, then my dad brought home one day a IBM PC clone that was an AT, so it was a 286.
Horrible computer.
It was, but I did all my early development work on a 286.
Oh, I used them. Yeah, the job I had required me to be a IBM convert.
So when you were in a job and having to be an IBM convert, I was in high school and learning how to do basic programming and write DOS batch scripts. I did a lot of DOS batch scripts. I made my own menuing systems. I figured out how to use color and the like how to enable the color drivers for the display, so I could have colored text screens, and the graphics with the little blocks done with characters. That was actually all fun. But my love was the C64, and then later the Commodore Amiga, because of the games, of course, and the graphics was so great, and the sound was awesome. So
I'm having flashbacks.
So years later, all these years later, I'm approached by Hackaday. It wasn't Yasmin, it was Sophia Kravitz approached me and said, "Hey, do you want to do this thing we do called a hack chat?" And it's kind of like a live chat stream,
right?
And we think it would be great to have someone like you talk about auto routers and why people love or hate them. And Bill, you joined on that, and you asked some of the best questions and had some of the best comments, and so did Paul Stoffridgen. I probably never say his last name right. I'm sorry, Paul, if you're listening. He's another legend in the business, you know, a microcontroller legend. But after that, we got connected, and we started talking about using routing technology, because you were using Proteus at the time, but you were switching over to Altium, and and had a lot of questions, and we got to know each other. And so this year I'm like, yeah, and then of course I knew that you'd be great at Altium Live as a keynote speaker, and everyone loved your speech. It was the funniest thing and the coolest thing we've had.
I had to trust that you guys knew your audience, because I was going, you want what? You want me to tell stories?
They're people like you and me. They're people like you and me, Bill.
And they were tired after 3 days, and so it was a good way to cash out.
Yeah, just have something lighthearted at the end there. And we've had other similar legends like Joe Grand tell stories too, which was awesome. So, you know, you set the bar high, but what it meant was we've had this ongoing, where we're basically chatting like this, but via email for a couple of years.
Right.
And I thought, why can't we just do a live stream and do it publicly?
Right. And I'll have you know, I kept that email stream bereft of questions, Altium questions. I didn't make you into my support, right? I kept going to regular support rather than abuse the privilege of knowing you.
Well, you know, you can ask me anything anytime, because you're a friend.
I'm saving it for when I'm really stuck in a way you can't find it in the manual. Like, what's the best way, ... you know. But I will someday, trust me.
Oh, and I likewise will ask you plenty of questions. So, but I have one question for you this morning, because we are running a design competition right now, and it's not to see who can design the coolest thing. It's more just, I don't know if anyone's noticed, but we have this brand marketing team, and again, sorry, there's marketing, but actually this is really cool, so people should be interested. This brand marketing team have been making really beautiful, elegant videos that tell the story of electronics design, and it's Altium producing it, but it's not us. We're not talking about our products or any of that stuff. We're just showing what some people are doing, because it's really cool. And if anyone's seen it on YouTube, you've probably seen the Arduino story, and everyone in this industry by now knows, like, Arduino is a household name amongst engineers. So it's just really fascinating to see a real quick, you know, it's like a 1-minute documentary on how that whole thing happened, and what was their impetus for creating this amazing community and product that makes it super accessible to get started with any kind of microcontroller based design. And now,
because it's not the technology, that's a 10-year-old chip, 15-year-old chip that we used to use for keyboard controllers, but they made it so you could sit down and be working 20 minutes later, and that instead of a day to get your IDE set up. That
democratization of drivers and getting a chip up and running on a board.
Just blip, 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 and the light blinks. Yep. That was everything. My son
it is so fast and valuable for the entire industry. And there's now, of course, professional pathways where you can start in the Arduino IDE, but then if you want to get into a professional debug environment, you can very easily migrate from that to, say, Atmel Studio or whatever.
Though I do like what Dr. Eric Bugaton said, which about the pinout, and he said, it's crap. You hear me clapping and wooting in the audience, because I've often said that. Yeah,
it wasn't meant for high speed. It was meant for high school
I/O lines.
Robotics.
It was meant for I/O lines. Yeah.
Yeah, and so. But that's different, of course. You see some of the boards they're designing now, definitely.
Well, now they're doing they're doing the full bore analog, and they're doing high speed SPI and stuff. Yeah.
Yeah. So I just wanted to mention that. So there's this video on our Altium Stories channel, and so that's kind of the backstory. So this team is wanting to produce more really fascinating stories, and as a means of uncovering some of those things. So
Tom, can I call you back?
We've also got the COVID response, right, open source respirator. There's a lot of things like that. And so what they decided to do was make this competition and say, look, if you have a great idea and you're willing to talk about what it is you're designing and share this fascinating information about it, and not maybe there's intellectual property you want to hold close to your chest, that's fine, but you can still talk about what it is you're doing. Or maybe you're doing something completely open source or anything in between. It doesn't matter what it is. If you're willing to share any information about what cool, exciting projects you've done, or and it could be something underway, something you've already done in the past, but it's like, I made this or I designed this.
And you're talking about the contest, right?
Yeah. So the idea is...
And does it have to have been done in Altium, or can it just be anything?
I believe it does. And if you don't have access, that's okay. Just get a free eval and do something.
Okay. That's what I've been telling people, is get a 30-day. And you guys are good about extending the... Right, and you guys are good about extending a 30-day. If you just reach out to somebody and say, hey, I'd like another 30-day, my name's BilHerd, and I'm doing a project, they'll go with you on that.
Right. So
as long as they can call you later to sell it to you, they're good.
But
that's why we're here.
This is running from now until 31st of August. So if you look at that page for the contest, we just want a quick video. It doesn't have to be polished. Just use your phone, video yourself. We want some, an introduction about your who you are, what you do. If you're a creator, you're a maker, or you're a professional engineer, doesn't matter. What you're currently working on. If you want to show any screenshots, you can. Of course, always those beautiful 3D rotating your design around in 3D is usually the eye candy people love to see.
Yeah.
And
if you're a family member of an Altium employee, you need not apply.
Yeah, I would go in it, but I work for Altium, so I can't.
Right.
But here's the deal: free licenses. If you get, and we're not saying here it's just one person. We don't say how many people are going to get something out of this. There may be more than one. I don't know. Actually,
there's T-shirts and stuff too. Yeah, there's a bunch of prizes.
Top 5 entrants, free Altium designer license on 365 with Concord Pro. That's actually worth a lot. That's thousands. That's
thousands. Yeah.
That's about $12,000 worth right there. Official Altium T-shirt, shout out, and runner-ups will still get a cool T-shirt and shout out on social, which is good for your career. Anyway, I've posted the link to this page on the YouTube video description. So if anyone wants to make a submission, and again. You could also just email pr@altium.com. That's all you have to do, and
cool.
You can get a free eval and start. now. You got time. August 31st. There's plenty of time. So I'll just show you what I'm working on currently, because I would be entering
and then I'll
this.
show you one.
If I were not an employee, I'd be entering this competition. So this is, I've showed you this the last live stream. This is my stroboscope or stroboscopic tuner. I'll show you in 3D. So I haven't cleaned up that DRC violation yet there.
Oh, you know what? I'm streaming where they can't see you. Oh, shame on me.
No, I'm sorry. No, it's my fault, Bill, because I didn't share my screen to your. I'm going to start sharing. Sorry.
Yep. Sorry, Facebook. That's why you hear me talking to Ben but not seeing him. I'm an idiot.
No, it was me, because I didn't.
Oh, no, it was me, man.
Can you see my screen now on Skype?
Yes. Yeah.
Okay, so this was the old version of the design. And this one, I was going to use an ARM 7 TDMI chip, because ARM Cortexes hadn't really hit the market. So that gives you an idea of how long ago I designed this. It's about 10 years old, this design. So I decided to refactor it for this. So basically there's 8 LEDs in a circle there, and they flash in sequence, and you plug your instrument in and you tune it up. When the instrument's fundamental frequency, so guitar or violin, whatever, fundamental matches the speed of the counter driving the LEDs, they'll stop spinning. Right. That's how a stroboscopic tuner works.
And I might throw out there, the key to doing the 3D rotations you're doing is to hit the shift key first. Do you know how long it took me to figure that out?
Oh yeah, hold down shift and right mouse drag.
And right mouse. I'm left clicking, right clicking, I'm doing all, and then finally, as you use Altium more, you learn to start doing shift experiments. And then control right shift experiment.
Control right mouse, drag forward and backwards is zoom. So I've the board no longer matches my schematic. I've actually completely replaced it. I'm going to use an Atmega 32U4 because it has USB, and it's super. Again, Arduino. I can use the Arduino programming environment to get this thing to work like it. Once I've done the board, now the hardware is actually the hard problem. The software is easy because of that. So I can build a simple tuner device that can also be a USB MIDI controller. That's the idea. I'm going to put some other IOs on this in a prototyping area so I can experiment with drum trigger inputs and things like that.
Oh, cool.
I want to add some signal conditioning maybe, and add inputs for piezo sensors so I can make a little electronic drum pad or something like that. That's the idea. So that's what I'm working on.
When I was in high school, before dropping out, I made a synth, and I made capacitive sensitive controllers on the sides, similar to what. And you reminded me of that when you said drum pads, because I used them so I could do a rhythm while still playing the keyboard with slapping my fingers on the side of the thing.
Yeah. So anyway, cool. I stopped screen sharing, but I just wanted to show that's what I'm working on. So
okay, let me show you what I'm working on.
Yeah.
So I meant to show this last week. You and I have talked. I've been working on an open source radar before COVID hit, and then I kind of lost the impetus behind it. But so I'm building it in 2x2-inch modules, and this is a continuous wave frequency modulated radar, open source. And basically it's continuous wave, which means it sends out a frequency that's sweeping all the time. And when it comes in, it beats against the what you're sending, and you get that beat frequency, that Doppler shift. Sounds like an audio frequency at the end of the day if it's under 20 kilohertz. Well, this is the first module. This is a 20 kilohertz low-pass filter that allows you to put it into take the signal output of the radar and put it into the audio input of a laptop to process it.
Oh,
but
that's
what
cool.
made me think of our last conversation is here's another part that I had custom made, and it's the power connectors. I had these made in China at LHE Connector, and so it's got its own little custom because I wanted my own little connector all the time, anytime. And so I call that a herdware connector. But
okay, so
and I only had to buy 100.
So that gives you ground plus and minus, right? And you...
That one did. And then back in my analog days, I actually had 4 wires, but it was more confusing. I had 2 grounds, so I could have an analog ground, a digital ground, and a hot and cold, or digital power supply and an analog supply. I ended up, each board only does one function, so I ended up back at 3.
What did that cost you to get 100 of those custom little cables made up?
I want to say like $50 or something. And shipping was like then 35 or 40, so they're $1 each, but... Oh, so then I ended up buying like 3 times as many for the same price. That's the thing, is it's all in the setup.
Yeah.
So I think I ended up buying like 200 or 300 for like $10 more per 100 or something.
Wow. So it's really worth, like, if you're designing stuff all the time and you need to do a lot of bench prototyping, just to decide on some kind of form factor and go for it.
That's it. Yeah. That's my template in Altium, is a 2-inch by 2-inch, where I actually have little standoffs that I standardized on. I don't know if it'll focus, but those fit right in the corners. So every time I do one of my boards, I've got this nice little form factor.
That's great. It's great.
So, yeah. Fine. So it's like what enables you to do more of what you like to do, and that's what that's all about.
Okay, I'm getting pinged here saying apparently we lost your audio.
My audio?
Yeah, I can hear you, but apparently other people on YouTube can't. So that's a drag.
I don't know how to fix that. Yeah. Oh, I know what. Last week you right-clicked on me and then hit it for stream only.
Okay.
It's when you screen shared probably that you made it. Or
when I made it you only. It's
right. It's when you selected that XSplit screen. That XSplit screen needs its audio set. Probably. While you're doing that, I'll show something else that we were going to show the first time. Even though people can't hear me, they can see me. What is that? That's
the 6.
That's a Kim 1.
Kim 1.
That's a real Kim 1. Yep. This has been mine since the 80s. And the way I got this is Commodore had a contest. Not a contest. What we did was send us your old computer and we'll knock $100 off a Commodore 64. So we have just buckets of these Sinclairs for $50 each. People would buy them for $50, send it to us still in the box. And then the person that sent us this Kim 1 got $100 off their C64, TI-99s, Atari 400s, you name it. We had skids of these things.
Wow.
So
do you have any others left? That's worth something now. They're hard to get.
Who would have thought? Who would have? You know how much stuff I've thrown away over the years?
Oh, I know. We all have. So
my own stuff, other people's stuff.
I'm getting requests from our viewers to go back and show us that board you were working on again and explain it because they couldn't hear you.
Ah, okay. So here's the board, and it's a 2x2 inch. What Ben mentioned was find a form factor that you like sometimes. And this actually happens to also fit on pegboard. So I have some polyurethane pegboard, and I can do whole experiments of hooking these together. But what I was showing, so it's on 1.5 inch centers. I've got these custom, not custom, but I found nice little insertable legs that go in. And then I had this custom LHE connector made at LHE Connector in China. So it's kind of like the connector on a CD player, DVD player internally, but mine has either 3 or 4 wires, and then the white part is also custom. So I got bags of it for a couple $100, just huge bags of parts. And it was like $100 NRE, and then after that, each one of these costs like a dime or something. So by virtue, I did a bunch at once, too. Then I combined all the shipping and the NRE costs and everything.
So you're getting custom cable harnesses, you're getting custom transformers wound.
Yeah,
and it's
I'm an engineer.
It's all actually not that super expensive.
I found it online too. Yeah, just by doing searching. So what this does, though, since I'm doing an open source radar, continuous wave. It's a Doppler radar, if you want to think of it that way. And what it is we combine the signals, and there'll be lots of modules. This is the first one, 6 modules. or 4, depending on which hand. But this takes the two signals, beats them together, and then low passes the audio so it can go into your laptop and be processed by MATLAB or whatever you want to use. So this is just it's a Nyquist filter that meets the Nyquist criteria. So 20 kilohertz, cool. Anything below it goes through, anything above it rolls off at 3 dB per octave, which I actually threw on the analyzer, or on the sweep and watched it do it just to make sure it was working like I designed it.
Nice. Marsha's asking, did you do that board in Altium Designer? Of course.
I did. Sure. Yep. And black silk screen. I got the idea for black from Altium.
Cool. So you said this is an open source radar project. So that means it's going to be anyone who wants to build one will be able to. Where are you planning to host that? Is it going to be up on Hackaday or?
I plan on seeing how Hackaday would like to cover it if I sit down and explain the board. Ultimately, these will be on herdware.com for sale as either blank PCBs, or I stuffed up like 10 of them for the first batch.
I have a really cool suggestion. Shameless plug, of course. Altium 365. Put it up in the cloud, and then use.
Oh, is there a public part?
Well, here's the deal. You can actually use the free cloud-based viewer and embed it in your herdware.com page, so people can go there.
Oh, cool!
They don't even have to have any CAD software installed. They can do it on an iPad.
Works on the web.
But they can look at your schematics and cross-probe to the board and highlight the nets on the board.
Cool.
They do that whole sort of collaboration.
It doesn't work for a multi-board assembly, I found today.
They're still working on that. That's true.
Yeah. And the other thing is you can't use a hyphen in the name. It hates that too.
Oh, I didn't know about that. Well, I'll get back to Lee and let him know. And
it threw a "here's the characters we don't allow" error, and I just glanced at it and no, it was the hyphen. So
I wonder if that's to do with the HTTP-based API sort of stuff, because hyphens are used.
They mean minus signs. Yeah, but I don't like underscores, and you and I have talked about this, because if you put a net label down on a wire and there's an underscore, you can't see the underscore. So you have to assume there's an underscore or a space. So I use hyphens from the old days, so you always see like 5-volt hyphen DVD or something like that.
Got it. So what else? I wanted to show you. I was out late at night in my shed going through some stuff.
Because the temperature's better out there late at night.
Yeah, it's not air conditioned. That's true. I found these awesome books from back in the days when there were several electronics publications in Australia. There's really only one left now, called Silicon Chip.
Here's my book of the day, Motorola. It's got all the 1N and 2N numbers in it. I have the same in TI, but this is my Motorola version from the 70s. I love this.
Like it's not only retro computing is popular these days, also anything retro electronics really is kind of popular on YouTube and on the blogs out there. So I
Nixie
found this,
tubes. Oh, love Nixie tubes.
Found this. This is from, when was this published? Doesn't even say.
Oh, who's the author?
It was a publication called Electronics Today International, or ETI, which really was an Australian publication, but I think they were based in Sydney. But I think they called it ETI because they sold in New Zealand as well as Australia, and maybe one or two other places. But these guys were known for their audio amps and things. The projects, they had solid-state amplifier designs that were really actually the flagships of the time. And I realized somehow, I don't know how, I ended up with this. This book has speaker projects. It has...
crossovers, that kind of thing too.
Basic analog mix. Yes, got active and passive crossovers. But it has this gyrator-based graphic EQ. And I have one of these still. I have one of these. It's in my parents' basement in Sydney. I have to go and get it. But this graphic EQ was revolutionary because it was one of the first. I think this is from like 1980 or 78 or something. So this would be one of the first designs that actually used gyrator op amps instead of. So the whole thing's fallen apart because the binding's no good. One of the first ones that uses gyrator op amps.
What brand? Oh, you said it's in the schematic. This uses gyrator. If you look at your screen.
Yeah.
Yeah. This was the first. This was a Onkyo, and back then these graphic EQs you're talking about were full of big inductors, and they would only roll off at 3 dB per octave, not like 12 or 24 like we're used to today.
I have to take care of this. This is exceptionally hard to come by, and there's a lot of projects in here that even today people still build. This classic amp design called the ETI 480. It uses 2N3055 and MJ2955 in the.
We had a conversation about the 2N3055 about a month ago.
Yeah, and
3054, 3055. 55 is the P&P version, right? 54 is the NPN and 55 is the P&P.
Well, this one uses MJ2955 for P&P.
Okay.
And
it's same thing though. The 55 is P&P and 54 is NPN. I used to fix 8-track tape players. I would just keep swapping the outputs with those transistors, and I could get the transistors at Radio Shack. So I'd go buy the transistors at lunch and then go to the park after dinner and fix people's 8-tracks.
Sounds fun.
I had a little tackle box, and I'd fix for a few dollars or something. I had a 12-volt soldering iron.
So I found a few books like that. I actually have this other one too that's cool.
Who was the guy? Sims. What was Sims's first name? Clarence Howard Sims. He's real famous for having the collections of.
I think
Howard Sims. Yeah.
This one.
Yeah, he's
Sam's
real popular over at Hackaday.
This one here from Sam's Publishing. When was this published? So this is from America. This is from 1977. Guitar Amplifier Handbook.
That one looks familiar to me, actually.
This thing is full of classic tube and solid state amp schematics. This book was published for people who went into the service industry and wanted to repair these for a living, or worked for music. So it does not have Marshall, oddly enough. Marshall's the only one it's missing, but I have Marshall schematics somewhere else. But this one has Bogans, Ward's Airline, Epiphone, Harmony, K.
Probably not Macintosh.
Ampeg. Well, see, here's the thing. These are all guitar and bass amps, so they're not high-end audio. They're not hi-fi amps. They're amps that
they're meant to distort.
They distort. Yeah.
Yeah.
So I think I'll set myself
They use negative feedback instead of positive feedback.
I think I'll set myself a retirement project for when I'm old to go through. I'm going to keep these and one by one transcribe all those schematics into proper CAD and then have them on a website somewhere so people can. I mean, maybe someone's already done it. There's a lot of sites.
A friend of mine, Avi Friedman, goes to the VCF shows and whatnot, buys huge boxes of like the old VAX manuals, and then he dumps them into things, and it's like a preservation project. Yeah, he dumps them into the big page scanners, and he's saving boxes of manuals a box at a time from these. They give it to him just to take them out of the house, Yeah.
So
hey, so you want to talk about getting a PC board? I've had an interesting week. I got to use the material libraries in Altium, which always is fun, right? You go in, it's that time in the project where you're picking the properties that will then determine your trace widths and everything. And you and I have talked about controlled impedance versus controlled dielectric. And my question to you is, who do you know of the online order places, let's stick to those, that have affordable circuit board materials that are usable into the gigahertz? And right now for me, that's JLC PCB And PCBWay has it, but they're like the old prices. It's like $400 for a Rogers board versus $25 for some JL2313.
Yeah.
So what do you use?
Well, I would have said the same two companies, JLC, PCB, and PCBWay. Also, you could probably get this, although I haven't tried lately, through PCBcart.com.
Oshpark was trying to do speed theirs up.
Yeah, if I need something quick, I'd go with Sierra Circuits here locally. I mean, they have some offshore factories as well, not in China, but I think in India. And so, and then also there's, if I want really low cost and quick, I would still use Oshpark, because Oshpark won't offer things like Rogers.
Isola 408 they use. It's wonderful stuff.
They will do FR 408, which is a beautiful material because it's balanced.
Low loss too.
It gives you the best of both worlds without being super crazy expensive. Rogers material will give you optimum for RF and microwave. If you want really low loss for radio, microwave,
4003,
you really need And the difference with those materials is they use ceramic fillers and things like that, and it makes the materials hard to handle, makes them brittle.
Right.
And you don't make the whole board out of it either. You just make your outer microstrip layers. You know, you have top and bottom copper, and you have the next layers in your stack. If it's a 6 or 4 or 8 layer board, the next layers in your stack should be unbroken ground planes, because that gives you the microstrip line structure you need for high quality, signal propagation and low loss. And then you only need thin laminations on the outer layers, so your board remains very strong, because the inner layers, the bulk
are
of the
normal
board,
stuff.
It's going to be FR408 or FR4, which is cheap and very tough. But the outer layers are going to be your Rogers material.
Right.
So,
and I've seen where they'll even do just one side for Teflon, since Teflon is so expensive. You might have it just on the top layer, but not the bottom layer, so it's not even symmetrical when you get into some of that. Yeah,
Teflon is the lowest loss to date, as far as I know.
Teflon, yeah.
But nothing sticks to it. Teflon is your
tetraethyl fluoride.
that's the non-stick coating in your fry pan.
That turns out to kill birds. You know that, right? If you leave your fry pan on the stove, and it gets too hot, it'll kill the birds in your house.
That's really nasty.
That's why you don't see Teflon like you used to when we were growing up. They used to coat paper with it, and it turns out that we're full of Teflon. Because it doesn't break down and digest. It's Teflon.
Right. Yeah. It's heat resistant, acid resistant, everything resistant. It's very tough.
Hey,
material.
So I wanted to mention Oshpark is, they're well known for batching, right, which makes it affordable in threes. They were going to a rapid for their 4-layer, a rapid delivery service. I don't think it's out, but that sounds like a great idea to me, because that 408 is still some of the best stuff out there. And then there'd be a third player I could go to. Actually, second, because PCBWay is still a little expensive for this. It's hundreds versus 20s,
Yeah, and of course the other limitation because of batching is you have to use their layer stack. But really, to me, that's never been a problem, because you
standardize on it yourself then or something. Yeah,
I think actually it solves a problem for a lot of people. Because what they do is they give you a known grid layer stack, and I know they've gone as far as 8 layers now too. So if you
I didn't know that.
So even if you need to do something more complex, they have a layer stack that you can use. It'll be shared on a panel with other people, but it's controlled and it's going to give you the results that they talk about, the impedances they talk about. So
and it's low loss stuff.
Right, so I think what we need is I think they have this on their website. You can download actually a template file that has the layer stack in it, so you can import it.
Well, I wanted to do that for like the various companies, PCBWay and JLC, pre-make the layer stacks for Altium. And you and me talked around that time. I got kind of hung up trying to like make the library be everything that I wanted it to be. But yeah, I was trying to do that so you could just like pull OshParks and it'd be right there in your Altium.
But even if you're not using these service providers, there's a lot of people out there.
It's quick to do your own layer stack management. It's actually fun.
Make a template. Make a template.
Yeah.
Make a template for the most common layer stack you use for most of your designs for a particular PCB fab that
Find the preset directory, drop it in there.
Set up a PCB document with that layer stack up in it, the materials in it, the impedance profiles in it, and the design rules as well. So you know what that fab can do for via aspect ratio, you know what minimum annular ring they want, clearance, trace widths, you name it. Put it all in there, set it up, and then make that your default for every new board you create. Saves you tons of time.
Right.
Template.
And I started a project recently and found myself going, oh, yep, got to do the DRCs. Oh, yep, got to, all the little things. There's like 5 little things that if I would remember to do them when I'm not in the middle of a project, that'd be great.
So I showed you some of my old schematic books. What other old cool stuff have you got going on there today? You flash up the Kim one every now and then, but if you got...
Well, the Kim one was based on the 6502, and as we know, Chuck Peddle just passed away in December. And at VCF, we were going to have Bill Mensch, who is the designer of the 6502. Chuck Peddle's the father of all 6502-ness, which is Apple. It's all these other brands in addition to Commodore. And the 6502 was made by Synertech, MOS Technology, and Rockwell, military grade. And so this was basically started as a way for them to demo the 6502. And when Chuck Peddle was asked, he said, well, what was your involvement with this? He said, well, it has calculator keys. That should tell you. Chuck was not a calculator guy. He was from the VAX side of the house at Motorola. Uh-huh. So what he was saying was somebody else did this actual design.
It wouldn't have been how he would do it.
The keyboard.
How many engineers does it take to change a light bulb?
In Australia or America? Which way does the light bulb screw? Your way, by the way.
It doesn't.
We use bayonet. I beat you to it. So what's cool about here?
How many engineers does it take to change a light bulb?
I don't know. I have no imagination left.
100. One to actually change it, and 99 others to stand around and say they would have done it differently.
I would have said 777 just because I started in the days of Octal. That's actually how we used to write protect our file, is set the version to 777. And it would go, I can't write the file. There's no number big enough that we can advance to. And that's how I would write protect my files.
That's God's number, right? But anyway, not
God in Australia or America. So, one thing I wanted to mention, though. Back in this day, EEPROMs couldn't run at a megahertz. So we would slow the clock down to 0.5 megahertz to 500 kilohertz clock whenever we accessed an EEPROM. And EEPROMs were ugly. They needed 3 voltages, -5, +5, +15, and then 24 for programming, so 4 altogether. So in these 2 chips here was a 0.5 K of mask ROM. And you had to pay thousands for the mask. Nowadays it'd be 10 or 20,000 for the masking, a read-only memory. But back then it was still affordable because EEPROMs were so frickin' slow that what we would do is put as much code into the ROM as we could and then have an EEPROM. And if we had to correct something, then we'd pull out just that routine into the EEPROM. But we'd use the EEPROM as kind of a kernel to jump to the fast routines in ROM. So there's a whole technology. And the timers, I got to talk with Bill Mensch about the timers on this and how he improved them for the 6522. And that to me is like, my whole career is based on the 6502. And so here we just had not only the passing of Chuck, but I got to talk with Mensch. Again, I talked with him 30 years ago. Thankfully, he doesn't remember. But and we're still hoping, yeah, I was a little arrogant. We're still hoping to, do a VCF and get Bill Mensch involved and do a big, long talk about how he did the 6502 when one didn't exist before him, right?
Yeah.
That's a true pioneer. He had to make depletion mode work, which is how you pull things up in NMOS. PMOS, you can pull things down easily. NMOS, you can pull things down easily. PMOS, you can pull them up. CMOS, you can pull them. That's why we use CMOS today. But he had to invent a way for NMOS to still pull high. And he did. And my whole career is based on that one transistor is way to think of it. Wow. Yeah.
Well,
amazing people.
And there's
amazing times.
There's this Western Design Center that kept the 6502 alive in silicon, right?
He talked about how he got the intellectual property. He got sued. Then they settled, and he got the rights to make the CMOS version of the 6502 out of the deal. But right, so we sued him.
But to this day, if you want to build a computer or simple control system using that platform, you can, and there's microcontrollers available. So it's pretty cool.
There's still I asked Chuck Peddle. There's a video. Maybe you can link to it after if in the post show or something, where Jerry Ellsworth and I interviewed Chuck Peddle, and I showed a video of Bender the robot, and he's got a 6502, and he's going kill all humans. And then there's the Terminator, and you see that code going down the red screen. Well, that's 6502 code also. I'm like, Chuck, are you an evil genius bent on destroying the world or what? And his answer was, he answered me very seriously. He said the number of medical equipment and other type of equipment based on the 6502 is in the millions. And I said, so you've saved more lives than you've taken. And he laughed and said, yes, something like that. So, but imagine being able to ask him that, right? And showing him Bender the robot. I'm sure he had never seen Bender off of Futurama before,
Yeah. So there's a question came in on YouTube's. There's Vinod. You're facing an issue on diff pair routing, and you want to create a diff pair class from the schematic. That will work. You can do it in two places, right?
You
have to name the schematic nets, whatever the net name is, with the underscore P
underscore
for your
N
in
or
phase,
underscore P. Yep.
And underscore N for the complement, and put a diff pair directive, which is from the active bar. If you do that, you'll get a differential pair, and it will be added to the differential pair class, all differential pairs. But if you want to create a class, you can either do that in PCB pretty easily, but if you want to do it from schematic, what you need to do, let me just show you. Bill,
I was going to say, I also add a net class of Z50 at the same time, just so when I'm over in the PC board editor, I can choose whether I want true differential coupling or just treat them as two separate transmission lines.
Yeah, I'm just going to share my screen again so I can show this. This is pretty
And
pretty
you might mention the difference between positive and negative. If you define something as a plane or a signal, it flips the polarity of the copper.
Right, so just as an example, this is an unfinished design as well that I'm working on. This is the other thing I'm working on.
All mine are unfinished.
I wanted to build a little CPLD board with a Lattice Mark X02 because they're pretty low cost and you can do a lot with them. Okay, but just for argument's sake, okay, so down here, let's say down here, is that a good one? Yeah, these PLs with A and B can be programmed as diff pairs in the FPGA. So let's say I want to make a couple of diff pairs. I want to make two differential pairs, so that's 4 signals, right? And I want them all to be in the same class together so I can apply a design rule to all diff pairs within that class, like length matching, let's say. Well, that'll be done later in the PCB, but for now, to define the pairs in schematic and define the class, I'm just going to throw a net label on that. Let's call this PL8. We'll hit tab to edit the name. PL8 underscore P. PL8 underscore N. I'm hitting tab to get to the properties, by the way. This one's going to be PL9 underscore P.
And if you cover up that little railroad track symbol, you have to find it or hit escape to get out of this mode. And I've been stuck before when I first started, where a window popped up over the pause icon.
Oh, yeah.
And I'm wondering why nothing's working.
And so then I go to this, I'm right-clicking on the active bar where it says parameter set and go differential pair. Or you could go place, directives.
That's what I do, yeah.
Differential pair, if you can't find it. And this has to go on all of these, right? Now that will create two differential pairs. One of them will be named PL8 and the other will be named PL9. But to save schematic space and time, what I want to do instead, and this gives me an optional extra bonus, which is to create a class. So I'm going to call this a blanket and place this object called a blanket. The blanket goes around. I've placed this thing, it's called a blanket. It goes around those objects, and blankets are orthogonal, but you can place more than 4 vertices. It doesn't have to be a square or rectangle. You can go around different objects around the design.
I haven't used blankets. Yeah.
And the triangle minimizes it to undo its effect temporarily. Okay. And when the triangle's pointing down, you click on it, you can expand it. Any object contained within or touching the edge of the blanket now has an effect. So these nets, if I place the diff pair directive just in one place, touching the blanket, and that blanket contains those nets, that will automatically create those two differential pairs, or differential pairs from anything named like a differential pair with the underscore P and underscore N. And get this, to this differential pair directive, I can also add, I can create a diff pair net class. If I select this directive here, this directive, I can click in the properties panel, click add diff pair net class, and I give it a name. So this will be PL. So now this not only creates two diff pairs, it adds them to a diff pair class called PL, which I can then apply design rules for length tuning and clearance and whatever to. And so on the PCB side, once I haven't got a board in this project yet, but that's how you do it. So I'll stop sharing my screen and go back to the Skype. How do I?
So here's a question about differential pair then. Does the signal go racing down the P one and come back the negative one then?
No.
No. No, it does not.
In an analog microphone cable, it does.
Right.
Because at the other end, you have the P and the N.
A differential amplifier, yeah.
Well, no, not even. It depends on the mixer it's plugged into. But if it's a good quality one, it'll have a nice transformer, and the microphone cable will be completely galvanically isolated from the rest of the mixing console. The input that the microphone drives is a transformer winding that is the hot and the cold are on each end of the winding, and it is galvanically isolated from the rest of the preamplifier input stage. That is the only time, and the same thing happens on an analog telephone line, which no one seems to know about anymore. But that's when a differential pair is a true balanced line. But differential pairs on a PCB generally
there are
two
signals that, they actually propagate at the same time. And the reason we try and get the signal lengths the same is so that when they cross zero, they're doing it at the same time. So as Lee Ritchie said, it's really a zero crossing detector is what you're making half the time. And you want the transitions to line up. You don't want a transition to be late because you get the most DVDT out of both signals if they line up when they at the same time.
So why do we use diff pairs, Bill, on a PCB?
For what I just said, if I'm doing a zero crossing detector where I'm doing a differential signal which is not related to ground necessarily, they're related to each other, and I keep flipping the polarity on them, because they do propagate down the wire like this and then this, I want them to cross at the same time when they arrive. I don't want the plus one getting there first and then the negative one. I'll have my eye diagram, as we call it, will get smaller. My ability to discern information will get less.
But isn't that just, let's say, isn't that just making the board more complicated to design because we have to double all our signals up?
I can get away without differential a lot of the time. We have tricks from the old days. Yeah.
Again, like I think
it's for distance mostly. Well, no, that's not true. That's not true. I mean, DDR5, DDR4, all those are set up as diff pairs. Or I'm sorry, not diff pairs, but same length traces.
Yeah. So
yeah, I confused two things there. I'm sorry.
No. But I think the real reason we do it on boards is it's twofold.
You're going to say common mode rejection.
Yeah, so noise, it reduces EMI and
because noise is on EMI, both, and they should cancel.
Yeah, and it improves susceptibility to noise. But
and also do you know I've changed? Go ahead.
I was saying it also allows you then to switch at much lower voltages, which saves power.
And you can make it a current switch also if you want, as opposed to a voltage propagation. You can do things with current modes too.
Yeah.
I've changed my tune on the common mode aspect after hearing some of the people names I keep dropping, where the effect of that gets less and less, especially in lengths and stuff, and it becomes more about just the zero crossing detector. Because if you think about it, right when they're crossing zero, this trace is going low and this trace is going high. If there's a noise impulse on both, you screwed up the zero crossing for both signals. So I'll tell you, it's not a perfect thing to think, oh, if it's on both, they'll cancel. It's bad when they're actually dynamically switching and they both hiccup. I'd rather have this have a noise pulse at a different period of time than this one. I'd rather have it at a random period of time. So there's a whole school of thought about don't make them follow the same pattern. Make one go a random way and this one that way, and that way the noise doesn't get on both at the same time. And that's counterintuitive, and I love it.
Yeah.
I love that way of thinking.
And I'm not convinced. I'm still going to route them together.
In my mind, both are true, and both are false. Really,
for me, the reason to route them together is to get them the same length more easily. That's the reason, because you must have the true and its complement arrive at the gate that they're driving at the same time. Yeah. To your point before, you want that they have to align, or you end up with uncertainties.
Right. Now, in analog, it's about electrons, right? Because we said in a true analog circuit, the current really does flow down and back. But at high frequencies, it's about the EM field propagating down both, long before an electron will ever arrive there.
Yeah. Yeah, you got to think of it that way anyway. Think of it as a wavefront travel.
What it really does, I don't know. That's how I think about it. That's a great way to say that.
But like the signal is in the energy. It's in the wavefront.
It's in the energy. As Rick Hartley says, it's in the insulation. It's in the dielectric.
Yeah, that's true. At DC and very low frequencies like audio,
it's not right.
I saw
audio is DC to somebody like me. Probably you as well, right?
It is, but it shows you like the skin effect is another thing. So in we can actually use thin copper layers as planes in a PCB if you're doing high speed and RF. All the return paths will travel in the thin layer, no problem, and you actually get a shielding effect. But copper planes do not shield for audio, so there's an adverse effect to this that people forget. They think, oh, I'll get a lower noise audio device if I put it in an aluminium enclosure, or use copper foil shielding on the inside.
Yeah.
I'll use copper foil shielding. It'll reduce the noise susceptibility. Well, it'll stop very high frequencies because they're shorted out because of the skin effect.
Right.
In thin conductors. But at audio frequencies, the skin depth is so deep that it will not cancel any magnetic fields. So it will not shielding. Right. Shielding
unless
does
it's mu
not
metal.
Help you. Yeah, shielding right. does not help you, and the only way to get shielding that helps with magnetic fields is to use a ferromagnetic material like iron or
mu metal. We call it
mu metal.
Yeah,
it's nickel. It's a nickel alloy.
Right.
And that's not as high permeability as iron, but you need,
which is the whole black pad conversation we had last week about nickel in the finish.
Yeah, and for that reason, a lot of high-speed designs, you can't, if you're going over a few gigabits a second, you probably should not use ENIG.
Right.
Yeah.
Right.
We're at the top of the hour here, Bill.
We are.
Is there anything else you wanted to round out before we?
Well, you asked a question about analog design rules. So real quick, I'll just answer that and say there's one thing that's counterintuitive. In RF, we don't like to do a guard around signals because you're capacitively coupling noise stuff into it. But in analog, that's a perfectly valid technique, is to have a ground ring around your two. Let's say you have an inverting and non-inverting input. That way, any noise that is coming laterally has to go first through ground to get to it. So you can do that. And the other thing is, be aware of what the negative feedback path is. If you get a little bit of noise in your positive anywhere else, the negative feedback will try and take it out. But if you have noise in your negative feedback, then you've got noise. So we always laid out the negative feedback path first and made that hug the chip.
That is an excellent design tip. I love it. I should have used it. I recently designed an audio mixer preamp for my studio, and Ian's reminding me. We promised last week we'd talk about rooms and multi-channel, and we haven't done it.
It's too late. It's too late.
We'll have to do that next week. I'm sorry, Ian. We will. I'm going to write that into our show notes for next week before. We have notes that we do ahead of time, so we'll get that in there. I should have written it in. We will do it, though. I promise. Anyway.
Well, great talking with you again, dude.
Yeah, you too. While we're doing rooms, I'll save what I was going to say for around that discussion, because it does relate a lot more to analog and audio, and that was to do with op amps. And you just were saying negative feedback. The negative feedback route that first for, and this would apply
the most
to
careful.
Analog.
Yeah.
So let's pick up where we're. Next week we'll pick up where we're leaving off here, and we'll talk about multi-channel design while we're at it with rooms. And
blankets
and using rooms to change rules and things.
In regions.
We were talking about fine pitch BGAs last time, and you can use a room to give yourself some tight tolerance stuff just where the BGA is, but have looser things everywhere else.
I just did that this week twice to reduce the solder mask, solder mask expansion for chips that pins were too close for the standard rules for solder masks, not even for the routing, but to make sure I didn't get a solder mask sliver between pins.
Oh, yeah. All right, man. Well, thank you, Bill. It was great talking to you as always, and I look forward to doing this again next week. And
Ian, I got to dig crap like this out, right?
That thing looks awesome. Onkyo made good stuff. I don't know.
That's why I still have it.
But
it's mine from when I was 16. You know.
They made the like that was the high end in Australia when I was growing up. Like if you had that, your dad was a manager, not just a worker.
And before this, because the coils were so big, you couldn't get it near your speaker. You know, so you had to isolate it. You couldn't get near the turntable either, you know, from the motor. Yeah. So it was like way up on top of your stack would be one of these things or something.
Yeah.
So excellent. All right, let's start shutting down. That usually takes a minute here, and it was great talking with you. And we'll talk next week, and we'll promise to talk about stuff that we'll never get to that week either. So. By the way, Commodore shirt.
There's always going to be something more, so we'll never run out of material.
All right. You have a good weekend, man.
Yeah, you too.